Alright class, organic chemistry. This is my favorite part of the class to teach. I am an organic chemist, so I could be a little bit biased, but I want you to have some exposure to organic chemistry because some of you guys never have to take a chemistry class again after this. And some of you guys will move on to organic chemistry, so it's good for everyone to get a little bit of exposure of what is organic chemistry and what it has done for everyone, for our lives. Now, I want you to raise your hand if you've done any of the following in the past 12 hours. If you used lotion, raise your hand. I can't see you, but raise your hand anyway. If you took aspirin, if you took Advil, if you listened to a CD, this is a very old list, but hey, no judgment. Raise your hand if you're still listening to a CD. If you used soap, hopefully everyone's hands is up right now because they used soap in the last 24 hours. So all of these that I just mentioned, they are made in an organic chemistry lab, or they use organic chemistry to improve them. Plastic, drugs, medicine, anything that they say is synthetic, these are all organic chemistry. Now, organic chemistry revolves around carbon and hydrogen. Carbon and hydrogen, okay? Those are the main two, carbon and hydrogen. And sometimes we have sulfur, phosphorus, nitrogen, and halogen as part of this structure also, but mainly carbon and hydrogen. Now, if I was carbon, so we have a whole field of organic chemistry dedicated to carbon, right? We have a whole field dedicated to carbon. So other elements might get jealous that why carbon gets its own field of chemistry. The reason is because what carbon can do, no one else can do on a periodic table. This is what carbon can do. Carbon makes 4 bonds, and that's very key. Carbon makes 4 bonds. What carbon can do, almost no one else can do. Carbon makes 4 strong covalent bonds. Now, hydrogen makes 1 bond. Now, I will need you to remember this as we are doing organic chemistry. When you move on to your OChem classes, I need you to remember this. Carbon makes 4 bonds. Hydrogen makes 1 bond. Carbon makes 4 bonds. Hydrogen makes 1 bond. I want you to remember that. Now, we've done this before, but I want to go over it one more time to make sure you guys are on the same page. We're going to do Lewis structures for carbon atoms, okay? CH4 is an organic compound because I have nothing but carbon and hydrogen. I want you to draw the Lewis structure for this. You already know how to do this, but the way I want you to do it, put the carbon in the middle and you put the hydrogen around it. And I've taught you guys to count electrons. You don't even need to count electrons. After you do this, how many bonds does carbon have right now? 1, 2, 3, 4. Carbon is happy because remember, carbon needs 4 bonds, hydrogen needs 1 bond. Carbon 4, hydrogen 1. You can remember that for me. Okay, and the geometry is tetrahedral. It's a tetrahedral geometry. And the bonding angle is 109 degrees. Okay, now here is my next one. C2H6. I have 2 carbons. I'm going to attach the 2 carbons together. I have 6 hydrogen. So I'm going to give each carbon 3 hydrogen. I want to give each carbon 3 hydrogen. Okay. Now, is each carbon happy? 1, 2, 3, 4. 1, 2, 3, 4. Each carbon has 4 bonds around it. Yes, each carbon is happy. I'm going to put a smiley face because that's a creepy smiley face, but go with it. Because each carbon has 4 bonds. Carbon needs 4 bonds. I need you to remember that. Now, what's the geometry around each carbon? And remember, each carbon has 4 bonds, so the geometry around each carbon is tetrahedral. That has not changed. Tetrahedral still. So far, so good. Okay. Now, next one, C2H4. I have 2 carbons. I'm going to add them together. I have 4 hydrogen, so each carbon gets 2 hydrogen. Now, count how many bonds does each carbon have. 1, 2, 3. 1, 2, 3. Each carbon has only 3 bonds. But carbon needs how many bonds? 4. So I need 1 extra bond. What do? I make a double bond. So carbon needs 4 bonds. Doesn't have it. Make a double bond. What's the geometry around each carbon? Again, it would be the geometry around each carbon. You have 1, 2, 3 things around it. So it would be trigonal planar. Because again, you have 3 things around the carbon. Trigonal planar. And the bond angle is 120 degrees. So far, so good. Okay, again, this was the geometry around each carbon, because each carbon has 1, 2, 3 bond around it, 1, 2, 3 things around it. Around each carbon, the geometry would be trigonal planar. So far, so good. C2H2. Again, we've done this before, that's why I'm going a little bit faster. I want to attach the carbons together. I have 2 hydrogen, so each carbon gets 1 hydrogen. Now, is the carbon happy? The carbon is not happy. 1, 2, 1, 2. Each carbon has 2 bonds. How many bonds does it need? Carbon needs 4 bonds, so I'm going to make it a triple bond. Now, this carbon has 1, 2, 3, 4. This carbon has 1, 2, 3, 4. I'm good. What's the geometry? Linear. So I've taught you guys to count electrons, and you can definitely do that. But with organic chemistry, organic molecules, carbon and hydrogen, it's even easier. Just make sure carbon has 4 bonds, hydrogen 1 bond. If carbon does not have a 4 bond, you have to start making double bond and triple bond. So far, so good. All right, beautiful. Now, we have a group of compounds called hydrocarbons. I've been talking about this all semester long, a little bit. Hydrocarbons are compounds that have nothing but carbon and hydrogen. So hydrocarbons are compounds that have nothing but carbon and hydrogen. Okay? Those are hydrocarbons. There's 3 types of hydrocarbons that we have. We have 3 types of hydrocarbon. The first one are called alkanes. Okay. The second one, they are called alkenes. And the last one is called alkynes. Again, hydrocarbons they have nothing but carbon and hydrogen. And they have 3 types: alkane, alkene, alkyne. Now, what's an alkane? Alkane is when all the carbons are connected by single bonds. All the carbons are connected by single bonds. That's called alkane. Let's come back over here. H6 is an alkane because all the carbons are connected by single bond. This is an alkane. Okay? So alkane is when we have nothing but single bonds. There is another name for alkane. The other name for alkane is called, they also call it saturated hydrocarbons. Saturated hydrocarbons. That's another name for alkanes. Now, this is so cool because where have you heard that phrase before? Saturated fat, right? People talk about it all the time. What do you think saturated fats are? Carbons that are connected by single bonds. That's kind of cool. Again, I can be a little biased, but I think it's really, really cool. So, hydrocarbons are made from nothing but carbon and hydrogen. If the carbons are connected by single bonds only, then we call it alkane. Now, let's go to alkene. Alkene is when you have 1 or more double bonds. Okay? So now at least 1 or more carbons are connected by double bonds. Give me an example. You know the example. C2H4, 1 or more double bonds. I have a double bond, so this is an alkene. Now, what do you think alkyne is? Alkyne is when you have one or more triple bond. So the carbons are connected together by at least one triple bond, then you call that alkyne. Tell me, give me an example. What do you know? C2H2, right? This is an example. We have one carbon-carbon triple bond. Carbon-carbon triple bond, this is alkyne. Alkene, alkane. Alkane, alkene, alkyne. We're good? Okay. Beautiful, 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 beautiful so far. Now, one thing I want you to remember, so alkane are carbon-carbon single bonds. Alkene are carbon-carbon double bonds. And alkyne are carbon-carbon triple bond. I've exaggerated a little bit, but it gets the point. And as you can see over here, the alkane single bond is going to be the longest bond. And the triple bond is going to be the shortest. It's the shortest, but it's the strongest because you have to put in more energy to break up all this bond. And alkane would be longest, but it would be the weakest bond. So far, so good. Beautiful. Okay. Now, what we're going to talk about right now, and is very important in organic chemistry, is naming. Naming is very important, and I want to tell you why. And the system of naming we're going to talk about is IUPAC. Don't write this down, but what IUPAC stands for is International Union of Pure and Applied Chemistry. You can see why I didn't want you to even write it down, because I was struggling with it a little bit. So International Union of Pure and Applied Chemistry. Now, why IUPAC matters is an international system of naming. And the reason we do that, so everyone is on the same page. A part of the organic chemistry, not the biggest part, but part of it is making drugs, right? Making drugs. Now, if I discover a drug and I name it, I want someone in Europe and someone in Asia read my name, the name of the drug that I have, and know exactly what is the structure of that. So we want to be on the same page. It doesn't matter where you are, as long as you use this IUPAC, this system of naming. When I'm talking about compound A and I have this name for it, someone else will have exactly the same name, so we can communicate. We can communicate better if we have the same international system of naming. Now, the first one we're going to go over, of course, we're going to go over alkanes. So that's the one that all the carbons are carbon-carbon single bond. Couple things about alkane to know. Again, you only have carbon-carbon single bonds, right? Alkane is when we have carbon-carbon single bonds. And alkane have one common use. You're going to say only one common use? Are they really useful? It's very useful. That one common use is fuel. Yes. Any kind of fuel you use, those are alkane. So what do you put in your car in order to drive it? I mean, if you have an electric car, that's a different story. But most of us go get gas, put it in our car, and then drive it. Next time, when you want to go get gas, instead of saying, I need to go get gas, you can impress someone and say, I'm going to go and get some alkane for my car. Completely joking about impressing someone. Usually when I use chemistry jokes or chemistry to strike a conversation with someone, that conversation dies pretty quickly. So don't use it, but it's still pretty cool that what you put in your car are alkanes or hydrocarbons. Now, go to a new page if you don't have half a page. So we're going to go over naming, right? I'm going to put up a chart. And the chart is going to say number of carbon, okay? And then it's going to have prefix, and is going to have the name, and then is going to have the formula. Okay, let's do this. Now, if you have one carbon, the prefix is meth, the name is methane. Now remember, right now, what am I talking about? I'm talking about alkane, right? Do you see where the name comes from? Methane. It comes from alkane, methane, ane. And the formula is CH4 because I have one carbon and carbon needs 4 bonds, so 4 bonded bonds to hydrogen. Again, I'm talking about alkane is just single bond. It's just single bond. Next one. Let's say if I have 2 carbon atoms. The prefix is eth. That would be ethane. Again, all the ending would be ane, ethane. 2 carbon, C2, H6. Okay, because all single bond. What if I have 3 carbon atoms? The prefix is prop and the name is propane. So 3 carbon and H8. Propane, you have heard of that before. Barbecue. 4th of July, when you're barbecuing, think about this. Or anytime you barbecue and you go, oh, I'm using propane to make the barbecue going. I know the formula of propane is C3H8. It's an alkane. People will definitely be impressed. Now, number 4. 4 is bute. So the name would be butane. Again, they're all ane because they're alkane. And they're all going to have nothing but single bonds. Okay? Now, after 4, it gets easier because it just become the Greek letters. 5 would be pent, right? Like pentagon, 5 side. So the name would be pentane. Now, tell me the formula. People who likes to see pattern. The formula would be C5H what? Hopefully you're yelling 12. Good job. Good job. See the pattern. A lot of organic chemistry is seeing the pattern. 6, you know. If you have something with a 6 sides, what do you call it? Hexagon, right? Is hex. Hexane. Again, ends with ane. C6H14. 7 would be hept. So heptane, right? It would be C7H16. See the pattern. Okay, beautiful. What is 8? Oct, right? Oct. It would be octane. It would be octane. C8H18. Almost there. 9. Non. It would be nonane. C9H20. Okay, last one you need for this class. 10 would be dec. It would be decane. C10H, tell me. 22. Beautiful. So, again, know the prefixes and then you're going to know these names, right? As long as you know the prefixes, you just add an N to the end and that's my alkane. Now, I need you to, again, you saw the pattern. Organic chemistry is seeing the pattern, a lot of it. Now, the formula, here's the formula for alkane. Number of hydrogen equals number of hydrogen for alkane. And let me be very clear. Number of hydrogen for alkane equals, here's the formula, would be number of carbon times 2 plus 2. Okay? So, for example, let's do an example. For example, if I have 8 carbon, right? It would be 8 times 2 plus 2. 8 times 2 is 16 plus 2 is 18. Oh, I cannot do math in my head. So it would be C8H18. Let's come back over here. Is that what we got? Oh, please be. Yes, it is. C8H18. Okay, so number of carbon times 2 plus 2, give you the formula, number of hydrogen for alkane. Because alkane is nothing but single bond. Let's do another example. You ready? What if I have 15 carbon? How many hydrogen would I have for alkane? So, it would be 15 times 2 plus 2. That would be 32. So, my formula would be C15H32 for alkane. Again, keen and kind are different. For alkane, this is what I would get. You guys feel pretty good about this? Alright. Do you just love these? Yes, these are fun. Now, we're going to talk about writing and drawing organic molecules. Okay? For example, let's do pentane. We want to write and draw organic molecules. There are a few different ways to do it. The first type, what you can do, you can write the molecular formula. That's easy. So I said I have pentane. Okay? If I say I have pentane, ends with ane, so you know everything is single bond, right? SP for single bond because it's pentane. Okay. Pentane means 5, right? So what's going to happen is going to be C5. Now how many hydrogen? Number of carbon times 2 plus 2. 5 carbon times 2 is 10 plus 2 is 12. So that's a molecular formula. That's one way to write organic molecules. Molecular formula. Pentane is C5H12. Now another way is expanded structural formula, which is Lewis structure. Basically. Okay? So let's do this together. I have 5 carbon atoms, okay? I have 5 carbon atoms. So I'm going to attach the 5 carbon atoms together. 1, 2, 3, 4, 5 carbon atoms together. You guys are good so far? Okay. Now, remember what we talked about. This is very, very key. Carbon needs how many bonds? 4 bonds. Hydrogen needs how many bonds? 1 bond. Okay, so I know I have 5 carbon. I attached all the carbons together. I connected all the carbons together. I have 12 hydrogen to account for, but it's easy to do. How many bonds does this carbon have right now? 1. How many more does it need? 3 more, right? So what I'm going to do, I'm going to put 1, 2, 3 hydrogen. Okay, this carbon over here, it has 2 bonds. How many more does it need? 2 more, because carbon needs 4 bonds. So I'm going to go 1, 2. This carbon over here, it has 2 bonds. How many more does it need? 4 total. It needs 2 more. I'm going to do 1, 2. The same here, it has 2 bonds. It needs 2 more. How about this one over here? It has 1. So how many more does it need? It needs 3 more to be 4. Again, I added a hydrogen, counting that each carbon needs 4 bonds. Now count the hydrogen. Are they matching? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, it matches up. I knew it was going to match up because this is pentane. It's an alkane. There's all single bond, no double bond or triple bond. I'm just going to put the hydrogens around it. Now, this is kind of tedious, isn't it? If I have like 32 carbon, for example, that's going to take me a long time to draw this out. So organic chemists go, this is cool, but this is a little too much. What we're going to do, we're going to do condensed. We are going to do condensed structural formula. We're going to do condensed structural formula. Okay? Now, I need you to pay attention to this. Here's the condensed. You see over here, I have a carbon and 3 hydrogen. Yeah? Here, I have a carbon attached to 3 hydrogen. So what I'm going to write CH3. And then this carbon is attached to another carbon. Now this carbon has how many? Has only 2 hydrogen. So this CH3 is attached to a CH2. Is attached to a CH2. This CH2 is attached to what? A carbon with 2 hydrogen with another CH2. and this is attached to another CH2. So here's CH2. Here's another CH2. You guys are following me so far? So this goes over here, CH2 attached to a CH2 attached to a CH2. What is the last one attached to? The last one is attached to a CH. This is a CH3, right? It's a CH3. So I'm going to draw a CH3. No. There we go. That's a condensed structure. A little bit easier, right? I don't have to show all the bonds because I know everything has 4 bonds and then everything is single bond. Now again, here's the problem. This one, what the problem is, it doesn't really show the geometry, does it? We know it's tetrahedral. We know the geometry is tetrahedral because when carbon has 4 bonds around it, it has a tetrahedral geometry. When carbon has 4 bonds around it, it's a tetrahedral geometry. But it doesn't show the geometry. So here's what we want to do. What we want to do, we want to somehow, a little bit, to show the geometry. It's not going to be perfect, but we want to show the geometry a little bit. The way to do that is doing a zigzag. Because tetrahedral, again, to do it, again, not a perfect way, but to do a zigzag. So I have a CH3 attached to a CH2, attached to a CH2, attached to a CH2, attached to a CH3. It's the same thing as before. Now I'm just doing a zigzag to show a little bit of the tetrahedral geometry. Again, it's not perfect, but it's better than this linear geometry that I have here. I'm showing the tetrahedral geometry just a little bit more, right? Again, because these are better to show the geometry, but I'm trying to do it a little bit using a zigzag. You following me so far? Okay. Now, even this is too much for organic chemists. We don't have time for this. We want to go make it even easier. And the last one, so this is even too much. The last one, which is my favorite, is skeletal formula. And this is the most sophisticated one. And I think it's actually the easiest one. You ready? This is going to be crazy. You're going to go, what is going on? This is it. This is pentane. What just happened? What just happened? Here's what just happened. Each corner represents a carbon. Okay? We have the zigzag. Remember how we had the zigzag here? How we had the zigzag here? So we have the zigzag over here. And then you're going to write each corner represents a carbon. 1, 2, 3, 4, 5 carbon. And we don't draw the hydrogens because we know they're there. Right? We don't draw the hydrogen because we know they're there. So each corner represents a carbon and we do not draw the hydrogen because we know the hydrogens are there. Pretty cool, isn't it? So let's do a little practice right now. What I want you to do, I want you to draw C10H22. Okay? It's an alkane. You know it's an alkane because number of carbon times 2 plus 2 matches it up, right? Okay? How many carbon? It has 10 carbon. I'm going to start with a zigzag. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you don't need to draw the hydrogen. This is so cool, right? It is very cool. Let's do one more. Let's draw hexane. Okay? Again, if I go hexane, it's an alkane. Hexane has what? How many carbon? 6 carbon. Is an ane, so it's an alkane. Number of carbon times 2 plus 2. 6 times 2 plus 2 is H14. Now I know I have 6 carbon, so I'm going to do is 1, 2, 3, 4, 5, 6. What just happened? 1, 2, 3, 4, 5, 6. Now, if you want to draw it from the other way, that's okay too. I can also go 1, 2, 3, 4, 5, 6. These are exactly the same thing. 1, 2, 3, 4, 5, 6. This is the same thing, okay? You can start a zigzag from up or from the down, doesn't matter. Now, here's what I want you to do as a practice. We don't draw the hydrogen, but we just know the hydrogens are there, right? What I want you to do, I actually want you to draw the hydrogen on this one. Let's draw the hydrogen to convince you the hydrogens are there and there are actually 14 hydrogen. Let's do it. So if I come over here, this carbon, okay, so let's draw this hydrogen. This carbon has only one bond. It needs 3 more. So I'm going to draw 3 hydrogen. This carbon has how many bonds? 1, 2. It needs 2 more. So I'm going to draw 2 hydrogen to be 4, right? This carbon has 2 bonds. It needs 2 more. So I need 2 more hydrogen. The same here, it has 2 bonds. It needs 2 more hydrogen. The same over here, it has 1, 2 bonds. It needs 2 more to be 4. So 2 hydrogen because I need 4. And then this one has only 1 bond. How many more does it need? It needs 3 more because carbon needs to have 4 bonds. Carbon needs to have 4 bonds. All right, add them all together. What do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This is what we don't drawing. We know it's going to work out, right? All right, skeletal formula. This is how I want you to do it. I want you to be sophisticated because being sophisticated is actually a little bit easier, right? Okay, we're almost there. So alkane, you got the alkane. Now, the next thing I want to do cycloalkane. We're still talking about alkane. So cycloalkane, what they are alkanes in a ring. So they still have just single bonds, but they're alkanes in a ring. How would you name them? You would just do cyclo and then the alkane name. So you just, let me do this a different color. So to name him, you would just say cyclo and then here you would just put the alkane name. Let's go over this to see what I mean by this. Let's do some example. You ready? What is this? You're probably going to say this is a triangle, but it's not a triangle, okay? In organic chemistry, this is not a triangle. What this is an cycloalkane. It's a ring. How many carbons in this ring? 1, 2, 3 carbon. If you have 3, what are you? You're propane. So what would be the name for this? It would be cyclopropane because 3 carbon is propane. Where did my thing go? Right? So again, you gotta know these prefixes for me. Ready for next one? Let's do another one. Again, this looks like algebra geometry to you, but it's not. How would you name this one? Help me out. 1, 2, 3, 4, 5 carbon. So this is a cyclopentane. Okay. Now, let's do this the other way. You ready? This is kind of cool. Now, let's say I want you to draw cyclohexane. Draw cyclohexane. How would you draw cyclohexane? Okay, pause me and draw this. Now, if I'm going to draw cyclohexane, that means I have 6 carbon, right? So I'm going to have 6 sides. It's like a hexagon. Now, I have 1, 2, 3, 4, 5, 6 carbons attached together in a ring. Cycloalkanes are carbons in a ring. So you don't have to be a straight line, straight chain. You can also be in a ring. Now, here's what I want you to do. You ready? So this is cyclohexane. If you're a cyclohexane, you have 6 carbon. I want you to count the hydrogen. Don't do the math, actually. Count, put down the hydrogen on this right now. Let's do it together. Let's put down the hydrogen here. So we know each carbon needs 4 bonds. Each carbon needs 4 bonds. How many bonds does this carbon have right now? 2. How many more does it need? It needs 2 more. How about this one right here? It has 2 bonds. How many does it need? It needs 2 more. Same here. It has 2 bonds. It needs 2 more. It has 2 bonds. It needs 2 more. Again, it has 2 bonds. This bond needs 2 more. Because carbon needs how many bonds? Repeat after me. It needs 4 bonds. All right. Count. the number of hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What just happened? If I had a hexane, how many carbon atoms would I get? 6 times 2 plus 2 is 14. But how come I only counted 12 here? Did I mess up? You did not mess up. For every ring, you lose 2 hydrogen. For every ring, you lose 2 hydrogen. Why do you lose 2 hydrogen? Because basically the carbons on the end are going to come together and they are going to bond together. So you need 2 less hydrogen. Because when, let me make sure you understand this. Let's say I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, right? You have this. Now, if I want to make a ring, these 2 carbons are going to come together, right? If these 2 carbons are going to come together, they're going to bond together. So then carbon only can make 4 bonds. They need to lose 2 hydrogen. Each one needs to lose a hydrogen so they can bond together. Because this has a CH3, this has 3 hydrogen, this has 3 hydrogen. But if these 2 want to come and bond together, each one would have to lose 1 hydrogen so they can bond together, because carbon cannot have more than 4 bonds. So what happens is you lose 2 hydrogen for every ring. We're good so far? Beautiful. Okay. Almost on the first part of our chem. I want to put a fun fact now. Let's do a fun fact. All right. Here's, again, you do not need to copy this down. Here's our fun fact. You ready? Guess what this is? It's bad for you, but it could also be good for you. If you eat a lot of avocado, you might get a lot of it. I'm not good at this game. This is, hopefully you guessed it right, cholesterol. Okay? Cholesterol. This is cholesterol. This is the structure of cholesterol. It's kind of cool now, right? You can see this. If you look at this structure of cholesterol, you're like, oh, I know what that is. That's pretty cool. Now, here's what I want you to do. I want you to look at this and tell me how many cycloalkane does it have? It has 4 cycloalkane. What type? If you have to name them, what would you think? It has 3 cyclohexane. It has 3 cyclohexane. And it has 1 cyclopentane. Okay, right here it has 1, 2, 3, 4, 5, 6, right? And then another cyclohexane. And then so it has 3 cyclohexane attached together. It has a cyclohexane attached together, and then it has a cyclopentane at the end. Okay, pretty cool, right? So cycloalkane, you know what they are. Now a little bit more fun fact before we go. Cholesterol. What's the function of cholesterol? We hear so much that cholesterol are bad for you, bad for you, bad for you. We sometimes forget that cholesterol, this compound, there is a reason for it. It has a function. What does it do? What cholesterol does, hopefully my biologists know, it makes hormone. It makes hormones. Now, because cholesterol makes hormones, it makes male hormone and female hormone. Because of that, hormones, estrogen, testosterone, male or female hormone, they all look very similar to cholesterol. You know how you look similar to your parents because your parents produced you? It's the same way. All the female or male hormones, because they're produced from cholesterol, they look like cholesterol. They all have these 3 cyclohexane and 1 cyclopentane, which is kind of cool. Now, let's talk about birth control pills. If you ever seen birth control pills, they are so tiny. I always wonder, how do you put everything that I need in a tiny pill? Now again, this goes back to organic chemistry and what organic chemistry has done for us. So in organic chemistry, in lab, we can synthesize the female hormone that we need. But then what organic chemists have realized is that what you could do, you could make the hormone, and what you can do after that, you can add a triple bond, an alkyne to it. When you make an alkyne to it, that becomes 1,000 times more reactive. So you don't need that much hormone. Small amount of hormone will give you the same effectiveness by adding a triple bond to it that makes it to be 1,000 times more reactive. So I want you to appreciate what organic chemistry has done. All right. I will see you guys at next lecture. Nice job.